Welcome to the Association of the Wall and Ceiling Industry webinar on delegated design. My name is Tao Nguyen, AWCI's Education Program Manager. Before we get started, I have a few announcements and housekeeping items. AWCI represents 2,400 companies and organizations in the acoustic ceiling systems, drywall system, exterior insulation and finish systems, fireproofing insulation, prefab, panelization, and stucco industries. Our members are contractors, suppliers, and manufacturers, and those in allied trades. Our mission is to provide services and undertake activities that enhance the members' ability to operate a successful business. Our next scheduled webinar will be September 12th, when Kelly McKay of the U.S. Drug Enforcement Agency will discuss the dangers of drug abuse and fentanyl in the construction industry. Our next annual meeting include the Industry Leaders Conference, October 17th through 20th at Boston Park Plaza Hotel in Boston, Massachusetts, and Build 24, AWCI's Convention and Expo, March 23rd through 27th in Orlando. Registration for the Industry Leaders Conference will open soon. Please visit our website, awci.org, for more information. A few housekeeping items. Our presenters will ask several poll questions during the webinar to check your understanding. Participants are expected to respond. All attendees are currently on mute. Should you have a question at any time during the broadcast, please submit it using the question box in your GoToWebinar dashboard. Our presenters will address any questions after each audience poll as well as the end of the webinar. This webinar is being recorded. The recording will be available on the AWCI YouTube channel in a few days. Handouts, including PDF of the presentation slides, are available now in the GoToWebinar sidebar. Click on the Handouts tab to download. And lastly, this course is not officially registered with any third parties, but may be eligible to be reported as a self-directed course if that option is available under the continuing education parameters of your program. All participants in the live version of this webinar will receive a certificate of attendance. No certificates will be issued for viewers of the recorded presentation. At this time, I'd like to introduce our two presenters, Andy Newland and Don Allen. Andy has more than 10 years of experience in both cold-formed steel manufacturing and design. Currently, he is a principal and the specialty structural team leader for AdTech's Charlottesville, Virginia, and Bay City, Michigan offices, which specialize in the design of load-bearing and non-load-bearing cold-formed steel framing. Andrew is a graduate of Virginia Tech, where he earned his BS in Civil and Environmental Engineering and MS in Civil Engineering. Our other presenter, Don, is an internationally known expert in cold-formed steel design and currently serves as Director of Technical Services for AWCI. He chairs the Education Committee of the American Iron and Steel Institute, is actively involved in the development of ASTM and AISI standards, and has designed projects in Europe, Africa, and North America. He can be reached at Allen, ALLEN, at awci.org. And off to you, Don.
Thank you very much for that rousing introduction, and thank you for presenting with me, Andy. And we are going to have a fun time today talking about delegated design disasters and how to solve them. So let's get right into it. First of all, we're going to cover these 5 learning objectives: what delegated design is, where you can find the requirements, both in specifications, drawings, and the building code, what the laws and code requirements are, who is responsible for the design, whether delegated or not, and how you can avoid the delegated design disasters we'll be talking about today, and most importantly, how you can avoid the costs that are associated with them. So first off, what is delegated design? Well, when you get a building built, it starts off with an owner who's got their wallet that they bring all this money with them, and they want to build a building typically, and the owner hires an architect. Now in the contracts, these are sometimes referred to as the building designer in the AISI, or American Iron and Steel Institute documents, or the primary design professional in the AIA, American Institute of Architects documents. So the architect becomes responsible for the design team, and they will hire a mechanical engineer, plumbing contractors, plumbing engineers, general contractors, and a specialty engineer. And the specialty engineer for, excuse me, this structural engineer of record, the structural engineer is responsible for the entire structure. So usually it starts with the foundations, concrete, structural steel, sometimes timber framing, but all of that is the responsibility of the structural engineer of record. Now, when they taught Andy and I in college how to do structural engineering, they taught us structural steel, concrete. We had some specialty classes on wood, on precast concrete, but they never taught us about cold form steel. It wasn't until we got out in the industry or went to some graduate level classes that we learned the specialty engineering in cold form steel. So because the structural engineer of record typically does not know that, does not understand it, and kind of has to learn that on the fly, they often delegate that design. And that is where you get to a specialty structural engineer. So it's not just cold form steel where this is done, but this is what we're going to focus on mostly today. And in the documents, it's referred to as either a delegated designer, specialty structural engineer. Sometimes they're hired by the general contractors, but most of the time they are hired by the drywall subcontractors. So folks like you are the ones that will hire these specialty structural engineers. And the ones that you hire, hopefully, are ones that better understand, have gone through that on-the-job training or taken special courses and understand the intricacies and the requirements of the cold form steel codes. So where is this in the law and the code requirements? So this is some states, and this is one example, the state of Florida, have a specific requirement written into the building code as what the delegated engineer is and what they're required to do. So this is the definition. If you can go through and Google the segment of the Florida code, the 61G15-30.002 definitions. And a delegated engineer in Florida is a professional engineer who undertakes specialty services, provides services, or creative work regarding a portion of the engineering project. They are the engineer of record, and that is a defined term as well, for that portion of the engineering project. So this spells out specific legal responsibility. So if something happens, somebody gets hurt, the project goes to court, there are damages, and Florida has had its share of collapses in the last few years. These engineers are liable for their portion of the work. They usually fall into one of these categories: independent consultant. Sometimes they're working for a manufacturer or supplier for many years. That's how I cut my teeth. I learned about this as working for a supplier of the product, or a fabricator or contractor. Some contractors have their own engineers on staff. And I know Andy's company had an engineer working for them who left and went to work for one of the AWCI member contracting firms. So there's a lot of different ways where you can have a delegated designer. There's another group called CASE, the Coalition of American Structural Engineers. And all this stuff is in the CASE documents, but what it means is the architect or the structural engineer of record can delegate the design. So it isn't always by the general contractor or the subcontractor, but the structural engineer of record still has ultimate responsibility for the overall design of the building. So they can't say, well, I delegate that off, so it's not my responsibility. You still have to submit the drawings to them. They still review the drawings. They may not know what they're looking for, but if that's, say, the load is coming into the bottom of the beam and they don't account for the beam twist, that's on them, the structural engineer of record. And the most important part to us, lines of communication must remain open between all members of the design and construction team. So as a specialty engineer, you must be able to reach out. You may have to go through the general contractor, or at least copy them on your correspondence, but you need to be able to contact the structural engineer of record, or SER. And when that line of communication is not open, it creates all sorts of problems. And I was actually involved with Andy on a project a few months ago where this happened, where the structural engineer of record was hard to get a hold of, was not communicative. I think he was a little embarrassed because he'd made some mistakes, but it was just very difficult getting that job built, but it eventually led to a successful project. So Andy, back to you.
All right, thanks, Don, and thanks for everyone for attending today. So delegated design submittals, there's, we're not the only ones who have to provide delegated design submittals. There's several others. Obviously, CFS is #1 on our list, but curtain walls, metal panels, brick and masonry, structural steel detailing out East Coast, trusses, post-tension concrete, metal deck, bar joist, and a lot of these other submittals are items that interact with our framing and what we're doing. So again, as Don mentioned, the communication with the delegated design professionals and the general contractors is important, because for a successful project, everyone has to work as a team, and there's a lot of teams that get involved when things start getting delegated. So the one place that you might find what other trades have their submittals delegated is the structural general notes. This is some text from a typical structural general note sheet, and you'll see some of the items that are listed that generally affect what we do. Post-tension concrete, that's a big one, with the tendons and all that, with our anchors, it's very important that we understand that. Some other items, aluminum occasionally, the window washing equipment, those can impart some heavy loads onto our framing. So if we're going to support the window washing equipment, we need to know it. That information needs to be provided to your engineer so that they can appropriately design it. The same thing goes with canopies. If the canopies are attached to the wall framing, that's information that you're going to need to get from the general contractor and provide to your specialty engineer. So what is delegated design with respect to wall and ceiling construction? A good place to look is the Code of Standard Practice. So this is a document that's produced by AISI, and it lays out the various responsibilities of a number of parties, including your specialty structural engineer. Some other things that are delegated: curtain wall design. That's something that's often delegated and we interact with on every single project. Floor and roof trusses, they typically have a similar code of standard practice that we deal with. But if you're dealing with ceilings, you might be attaching to the underside of them. So it's good to be familiar with their work. Structural steel and metal deck, if you're supporting them, and load-bearing framing, then it's important to realize those delegated submittals as well. So where are you going to find what's delegated? I mentioned in the structural general notes. Another good place to look is the specifications. So that might be the 5400 section or the 9216 section for interior. So specifically in the 5400 spec, you might see something like this that lays out what's specifically required in the submittals. And then you get to section E, where it specifically indicates that shop drawings are required. So, and what is required of the shop drawings, so this is something that you're going to provide to your specialty engineer so that they have this information as well. So they know what's required of their design and their submittals that you're then going to submit to the general contractor and the architect and engineer of record. I should note that in the handout, the headings on this slide and the next one are backwards. So just make a note of that, because there is a big difference from when you go from the 5400 to the 9216, 92216, because you don't see that requirement for shop drawings necessarily. You might have to submit product data. This does include shop drawings, but it's not to the extent that what the 5400 structural requires. So it's just something to be aware of. You want to read these specifications to know what actually is required of you and your engineer. So now this brings us to our first poll question. And hopefully you're all seeing the poll question and able to vote. There you go. So where in the contract documents might you find the requirements for a delegated design? The 5400 specification, the 09-2216 specification, the structural general notes, or any of the above. So we'll give you a few moments to answer, and then if anybody has any questions, as Tal mentioned at the beginning, put them in the chat and we should be able to answer some questions if they're out there. Good job, 83% of you. It should be any of the above. You know, the requirements are going to be noted in those areas. So that's where you want to look and get an idea of what's required of you and your specialty structural engineer.
All right, so even though Andy just told you, and most of you answered the question correctly, that not only in section 54,000, but also in 92216, there can be requirements for specialty structural engineering for shop drawings, as we call them. I call this an alarming trend, which is delegated design for interiors is on the rise, and there's not a good reason for it. Quite often, an architect will just pull an old spec or grab something and say, look, I want more of this stuff submitted, and they will require a specialty structural engineer like Andy, like myself, to do the design on interiors. And most of the time, this is not needed. Now, there are a few times where it is appropriate. They're up on your screen. If you're in a high seismic area and you have moderate to heavy finishes, the next slide, we'll talk about this a little bit as well. If you've got super long spans, it's something that you can't just look in a manufacturer's catalog and get a ceiling span or a wall span. If you have heavy interior finishes, I did a project in Charlotte, North Carolina one time. You don't think of North Carolina as being in much of a seismic zone, but they put this heavy stone veneer in the lobby of this magnificent office building, and because of the seismic design and its proximity to Charleston, South Carolina, it was going to cause that building to shake so much that that part of the design controls. So heavy finishes, high or even moderate seismic areas with those heavy finishes, and then higher than code loads. And for example, if you have a data center where they don't use the regular 5 PSF interior pressure, but they put something like 20 PSF or their blast requirements or something else, then you need to go ahead and hire a specialty structural engineer. But most of this stuff, most of you contractors that do this type of work, you've been doing it for years, you've been doing it for decades, you know how to make this work in most applications. And when you get a structural engineer involved, all that does is increase cost. You're getting to an area that's outside their specialty. You're getting into some requirements that, quite frankly, are not necessary for adequate performance of the building. So I say it is appropriate in these 5 bulleted areas. It's not appropriate with everything else. So when you see interior walls, the interior framing is considered non-structural framing, exterior walls, curtain walls, and load-bearing walls that carry the weight of the structure. That's considered load-bearing or structural framing. And AISI has 2 documents, AISI S240, which is for structural framing, that load-bearing studs or the wind-bearing studs on the outside, and AISI S220, which is for interior non-structure. In interior non-structural, they give these limits on how much load these non-structural members can carry. And it's limited to not more than 10 pounds per square foot, with this yellow caveat that if you're in a pressurized plenum, it can go up to 15. You can still use the non-structural studs on it. It's limited to item 2 below the highlight, no more than 100 pounds per foot of wall, or item 3, no more than 200 pounds per individual stud. So if you want to hang cabinets on the wall, there's studs behind it, and that cabinet is not going to impose any more than 200 pounds per stud, you can do that with non-structural studs. And you can sometimes do it, depending on what manufacturer's data you can get, without having to hire a specialty structural engineer. The limit for pressures in the building code, and it's a live load, not a wind load, but for interiors, these interior walls need to be designed for 5 pounds per square foot, and that's it, unless there's something in addition to that in the specifications. Sometimes you'll see for high-speed elevators, it'll be up to 10 or 15 pounds per square foot. So this leads us to the next poll question. What conditions are appropriate for delegated design on interior non-structural walls? see if you've been paying attention for the last couple minutes. 1, it's never appropriate. 2, heavy finishes, long spans higher than code loads. 3, delegated design should always be specified for interior walls. Or lastly, when the walls are supporting cabinets. So we'll leave the poll open for a minute or so, and it looks like we do have a question out there.
So this goes back to before, is the role of delegated engineer legally defined in all states, or does it just vary?
So I'll answer from what I know, which is it is defined in some states and not in others. And so what you should do is the engineer that is registered in that state, you should ask them and they can tell you whether or not it's defined. Andy, do you have additional information on that?
The correct response. I mean, you can go back to the Code of Standard Practice, which technically isn't enforceable, but you know, it's defined in there. And
right, that is true.
Applicable as well.
All right, so I cannot see the poll results. So Andrew, if you could read them back to us.
We got 86% said heavy finishes, long spans, higher than code loads. So I think 86% are paying attention.
Good job. All right, good job. Or guessed right. All right, great. Thank you.
Just a couple comments back
to
Andy's slides before. The horizontal shaft and vertical shaft may require engineering. The horizontal shaft anchorage is often missed during construction. That's the referred to, say 0922, 1623. And then
so a design requirement for shaft walls?
I think that was just a comment to keep an eye out for that. And then another one, do you know the official definition difference of delegated design versus deferred submittal?
Andy, I'll let you take that one.
I don't think I know the specific differences offhand. Don, do you?
So a delegated designer is, I think, the way it was defined in Florida. So the state defers it, the designer as the individual that provides that design. And then it talks about the design responsibilities. A deferred submittal may have definitions in different structural documents, and that's something that it comes after the fact. And a deferred submittal does not necessarily have to be done by an engineer. So you can have deferred submittals for items, let's say, that include a manufacturer's rep providing connection details, or let's say some company that makes brick ties or fasteners providing a design for those fasteners based on a certain amount of wind load. So that can be a deferred submittal, but you may not have to have a delegated engineer design those. So I think the deferred submittal is a little bit broader category, and it may be something subsubmittal that might be an architectural design that may not have been the responsibility of the purview of the structural engineer of record.
Okay, and then one of the questions, can AWC and SFIA lobby the manufacturers to all meet the same wall height limits for the same size members?
As far as the same wall heights for the same size members, there generally are the same for structural members. Where it is different is for non-structural members, and it's very competitive as the manufacturing companies work to come up with new shapes, more efficient sizes, ways to get less steel to perform better. Now, when you're looking at a green building and environmental standpoint, that's good, right? We've already engineered 30% of the weight of the carbon footprint out of the steel in our interior partitions for what people call EQ studs. With respect to contractors, it may not be as much good because you run up with different limiting height tables from different manufacturers. But in the areas that we as engineers are concerned about, the structural framing that are carrying the weight of the building, carrying the wind pressure, most of the manufacturers are pretty much the same. And usually those variations just have to do with some variations in analysis, things like the footnotes of the table. And I think Andy's going to be talking about that in a slide or two about these footnotes and tables and why the engineer design is a little different.
All right, so kind of continuing on with the non-structural components, something that you all should look out for. So This is an excerpt from ASC 716. So that document is specifically referenced by IBC 2018 and some newer versions. But so this is where the engineer record, your especially structural engineer, go to get the specific loads for the design. So in this case, we're dealing with the seismic design requirements for non-structural components. So those components are going to be your non-structural walls, your ceilings, and things like that. And so the one thing you want to pay attention to here is specifically the exemptions or exceptions, which ASC 7 has decided that they were going to use both words. So in 13.1.4, they provide a couple of exemptions, specifically furniture, except for storage cabinets. So kind of as Don had mentioned, when you have those heavier storage cabinets hanging on your walls, that's going to need to be designed for seismic. If you have architectural components in seismic design category B, that's also known as, you might see it as SDC on the structural general notes, and your component has an importance factor of that's equal to 1.0. So once you exceed that, then you're going to have a seismic analysis done on your non-structural components. For ceilings, if the area is less than or equal to 144 square foot and surrounded by walls or soffits that are laterally braced to the structure. So if it's all tied together and can't move, and it's smaller than 144 square foot, then you don't need to have a seismic analysis done, otherwise you do. So, and that quickly brings us to poll question number 3. So which parameters will allow seismic design to be excluded for non-structural framing per ASC 7? Furniture, not including your storage cabinets. Architectural components in seismic design category B, SDCB, with an importance factor of 1. A 144 square foot or less ACT ceiling with braced walls on all sides, or all of the above.
Someone just commented that deferred design is trending because the specialty structural engineer has no contractual relationship with the SER.
I think Dawn's actually kind of going to mention the relationship, I believe, Dawn or I. That, or no, Dawn did actually previously, that, you know, our relationships typically with the contractor, the subcontractor, or the general contractor, and not directly with the SER. 89% got it right. So yeah, so it is all of the above. Those all can be excluded for non-structural framing.
And I see there's another question here that says, I've always thought that the engineering fees should not have to fall on the metal framer, and the metal framers needs to know answers before confirmation. And I've been involved a lot of times over some drinks at a bar with talking to people about this, about where that delegated design belongs, and shouldn't the engineer of record be doing his or her job to complete the design. And the issue is, as we said before, a lot of times they don't know what they're doing, and we'll talk about this a little bit later. They try to do the design of the cold form steel framing, and they screw it up, and that causes problems for the people bidding the job if it's designed wrong up front. It causes problems with the people bidding the job, though, if the design is incomplete, which is another problem that you have when the engineer of record doesn't do it. So there's a lot of issues back and forth. We can't cover them all in the hour, but you need to be prepared, at least in 54,000, that there is very likely going to be a deferred design, deferred submittal, or especially engineering requirement. In Division 9, you may have it, so look closely just in case to make sure that you don't get bit by it and you've included it in your bid. All right.
And then one more question, does spring hung gypsum board ceilings require seismic design?
So I would say if you fall outside those exemptions or exceptions, then yes, it would be required.
Okay, that's all for the questions right now. Thank you.
All right, so we will go ahead and move forward to the next slide. Seismic for acoustical ceilings. Now, this is not a spring hung gypsum board. but this is another document that covers a lot of the same provisions as ASCE 7. NEHRP recommended seismic provisions for new buildings and other structures, FEMA P2082, Volume 1. And a lot of the provisions in this were pulled into and adopted into ASCE 7. The reason I point this out, this is not a code required document. It's not even referenced by the building code, but a lot of the provisions that are in here are the same provisions that are in ASCE 7, and this is a free download. So ASCE 7, you have to get it from the American Society of Civil Engineers. I don't think it's like the International Building Code where you can actually view it online. ASC, because they're an association, has to make money selling their books. So I don't think that you can get it free. Correct me if I'm wrong, you can put something in the notes or chats, but it's over $100, I think, even for ASCE members. So if you want to get this document, here's the place where you get the free download. What it has in it is a table in section C13.5, summary of requirements for acoustical tile or lay-in panel ceilings. This is back in the commentary. And by the way, for those of you that do have ASCE 7, there's a similar table in the commentary of that document, but it talks about all of the different requirements based on the size. So Andy was talking earlier about the 144 square foot areas. There are different requirements sometimes in seismic design category C or D, E, and F. And as you can see, if you're less than that area, there are no requirements in here. So then with the greater, then it talks about the different elements in that. So now this is not the entire table, so don't rely on this. The table goes on for 4 or 5 pages. I'm not going to talk about all of it. I just wanted you to know it was there and know that it's a free download that you could get to. Other resources that you can get to for seismic design of ceilings, AWCI has a YouTube channel. So the link to the channel itself is on the left. And the presentation, we had a couple folks from United States Gypsum come in back in February and give a presentation on seismic requirements in suspended ceiling design. They do a very thorough job of going through kind of the background of the requirements, what the seismic requirements are. They mention things like ASCE 7 as well as the ASTM standard E580, which addresses these ceiling issues. And they talk about that in their design. So again, this is a link to that video. It's about an hour long. And if you missed it in February, you can go watch it at your own speed now. I mentioned just a moment ago, ASTM standard E580. This contains a lot of the same requirements that are in ASCE 7. And these are often referenced in the architectural specifications. And of course, they are referenced in the building code. This gives a lot of the details for offset from the edge of the walls, how you could put the support wires in, the vertical supports and splay wire supports. So different requirements for different types of ceiling, but ASTM standard E580 gives those requirements. Again, this is not a free download. I think it's $63 for the latest version of the document, but if it's referenced in your standards and you're doing these kind of ceilings, it would be good to go ahead and get this document. So that brings up the question, who is responsible for the design? Andy, back to you.
All right. So as mentioned, the code is, I think a couple times now, the code of standard practice. So this is really going to lay out who is responsible for what. So when it all boils down to it, technically the engineer of record is responsible for the overall building. They're responsible for even what they delegate. So when they do delegate, they're also responsible for providing a lot of necessary information. So that's the appropriate building code, the appropriate loads that the delegated designers have to conform to. So whether that's gravity loads, lateral wind loads, if you're doing a load-bearing project, you know, the gravity loads that it's supporting, as well as any kind of lateral loads on a lateral system, shear walls, X-brace walls, that all of that information needs to be provided by the engineer of record. Oftentimes they shirk that duty, but it's according to the code of standard practice, that's information that they are required to provide, as well as a complete set of contract documents. So who's responsible for the design? The owner or contractor shall furnish to the CFS component manufacturer an installer a set of construction documents that would be prepared by the engineer of record and architect of record, including any addenda showing basically what's required of you. And your responsibility is limited to what's on the construction documents. And, as all of you know, per that first sentence there, that the construction documents are assumed to be correct in all details. And that happens every single time you get a completely perfect set of drawings and nothing's incorrect. Obviously, that's not the case, but you are limited to what's given to you and only responsible for that. So if things change, then they need to provide you with those changes so that you can address them, provide change orders as required, and to any changes that they make due to things that have changed in the drawings. So as I kind of mentioned, what kind of things do you want to look for? What information do you need? You do need a full set of drawings. So that's architectural and structural drawings. When I'm doing my design, absolutely need those things. They need to be the most up-to-date sets. If you send me a bid set and you're getting ready to build it in 2 weeks, there's going to be a newer set of drawings out there. We may need a set of mechanical drawings, especially with interior framing, to have an idea where mechanical ductwork piping is. The structural general note should have the code reference, and it should be matched the data the drawings provided. Again, they need to provide loads, wind, earthquake, snow, live, dead. There might be some others. You might see like rain or some other things in there as well. A full set of specifications, so that's the structural and then the non-structural specifications, as well as maybe some additional specifications if there's substitutions, some green building specifications as well. And for data centers, sometimes they might have a structural steeling specification. So if you're doing that type of work, that's something you also want to get and provide to your specialty engineer.
So before we continue on, someone asked, in this delegated design or deferred submittal, how is a sub expected to price work without knowing the sizing, gauges, and connections of the project or correct framing components? What do they do?
So that's something we're going to cover a little bit later on, but what you do is you make friends with a specialty engineer. You hire them for projects. You don't just use them, but a lot of times if you've been a repeat customer with these guys, or sometimes even if you pay them up front, they can give you preliminary sizing before you get the job. And what you have to do is, if you do get to the job, you've got to promise to work with those guys. So Andy, I'll let you comment on that as well, because you've got customers that treat you right and some that don't.
Yeah, that's absolutely true. You have your customers that you work with hand in hand that say, hey, can you look at this job before me? I'm bidding it. It's got some crazy tall spans. I don't know what to do. I think some subs have a good idea and have some software that they use that help them price stuff, but having that relationship with a specialty engineer that can give you some preliminary sizes that you can take to bid, can give you an advantage. So, and it builds a good relationship with an engineer.
And I'm looking, I see we've got several questions coming up here. I'm going to try to get to a couple of them before we get in these disaster examples. One is you're being required to use drilled anchors on the exterior wall, not PAFs. And I will say that I've specified lots of projects, Andy, I'm sure you've done the same thing, where you do use PAFs on the exterior walls, but you can't use the little 1/2 inch, 5/8 inch track pins. You have to use the longer connectors. You have to use the larger diameter pins, and they have to be able to be embedded into whatever is there, the concrete, or in some cases you've got structural steel. And a lot of times you have problems going into structural steel, or you've got post-tension concrete where they put limits on how far you can go into it. And if that's the case, you may have to find some other fastening method. And I think Cold Form Steel Engineers Institute has an entire webinar and a technical note on attaching to some of these framing pieces at the perimeter. So I haven't seen that as a requirement that can't be overcome, but sometimes you'll have a jurisdiction and you may have to bring in a specialty engineer to coordinate with them. Also, I see the question about what happens if you have a specialty partition or a fire rated wall or acoustically rated wall or acoustically rated or fire rated floor ceiling, and then somebody comes in and cuts a hole in it, then who's responsible for the design of that? So that's a sticky question, and the answer is not always the same depending on who cut what and where things are located. And only the structural design is the responsibility of the structural engineer of record and the specialty structural engineer. So you've got acoustical issues. The specialty engineers, people like me and Andy, are not experts in acoustics. And sometimes some of these structural connections that I want to make don't work for the acoustical design. So we have to learn a little bit about it and do it a little bit differently. Same with electrical and plumbing. A lot of times it's best to get involved with the design team very early on. We're going to talk about that in a minute, but sometimes it's not a simple answer. And I think this question, we could probably talk about that for quite a long time. So Tower, there are a couple other questions that
One
we might want
more.
to handle before.
Yeah, how is head of wall deflection vertical calculated at the delegated design level for interior partitions?
Andy, I'll let you take that one. And I think there's a AISC document on anticipated live load deflection. Are you aware of that?
I'm
Maybe
not aware
not.
of that one,
Okay.
but
Okay.
I mean, it might be out there, but I think the short answer is, they specify their deflection limits and, might be L over 360. A lot of times, you might see the required deflection and something, especially structural engineers, we like to see, whether it's the 5400 or the 92216 spec, you might see it in there. Very often you'll see it in the 5400. Sometimes you don't, and then, it might be required of you to figure it out, or your specialty structural engineer to figure it out. One of the stickier situations is when you're dealing with metal buildings and they have very large deflections. And I really think that that's something that if it's not provided, you should request, especially when you're doing a metal building, because those deflections can be extremely high when you have to start using some specialty products for your deflections at those interior head of wall connections.
Right. So a lot of times we design for live load deflection of L over 360. So if you've got a 30-foot span, that deflection can be over an inch. But the actual live load that you receive is quite often less than whatever that design live load is. So I think the rule of thumb is people design for about a third of that load. I'm not positive if anybody knows what that AISC document is. Please type it into the chat or type it into the question box, and we'll respond to that. I also see a comment that says, watch out for pre-engineered metal buildings, because even though we've been talking about live loads, you get some very high snow loads. I know Andy's in Virginia, I'm in Georgia, so we're not used to high snow loads, but yes, large areas of the country get these really high snow loads, and you get much higher deflections with those. So again, this is why you want to hire a specialty engineer to work with the engineer of record, maintain that communication so that you can get what that anticipated deflection is going to be and make sure and design your wall properly. So I'm going to move on. I know we've got some other things, questions in there. I'll let you evaluate which ones we can get to, but we're running a little close on time. So I want to get into some of these examples and, more importantly, the solutions for these examples. So disaster number one, we're going to cover 4 of them. You won, or even worse, you built the job and you find out afterwards that you totally missed the delegated design requirements hidden in the contract documents. So what do you do if you miss the requirements? Number one, you plead with the general contractor or the architect or the engineer or whoever put that requirement in there and explain your situation. Tell them, hey, look, I've been doing this for years. We've done similar projects. We use heavier, beefier framing. We use better studs, whatever it is, but try to get that coordinated and see if they'll let you off the hook for this thing. Now, a lot of times they don't get right back to you. They don't tell you immediately yes or no. They leave you hanging. So while that is happening, don't wait for an answer. Get with a specialty structural engineer. Hopefully you got one out there on speed dial someplace, or you've got a good relationship with one, if you don't know a specialty structural engineer, check with the Cold Form Steel Engineers Institute, cfsei.org. They've got a tab in there called Engineer Finder, and you can find somebody, call them up, find out what their price is and their time frame. And what they're going to need is they're going to need three things from you. They're going to need architectural drawings, structural drawings, the section of the specification that is requiring this. And what they will do is they will help you read through that specification section or read through the documents and see really what does it require, because it doesn't always require a full set of drawings and calculations. Now, I know when Andy does these jobs, when I used to do this kind of work, we would provide a full set of drawings, full set of calculations, put our seals on them, and that would be the entire package. But sometimes they'll just require calculations and not drawings, and that will save a lot of drafting time. And engineers are having almost as much trouble, not as much, but almost as much trouble finding good quality labor as contractors are nowadays, and good draftspeople are hard to come by. So if you can get a requirement that doesn't require you to provide drawings, but just requires calculations, you may be able to get your drawings and your submittals done a little bit more quickly. And sometimes the loopholes in the documents will say, hey, specialty engineers required just for connections not covered by manufacturer's standard details. Well, you might have enough details from the manufacturer and be able to submit those and cover 90% and just have a couple little connections or a couple little designs in there. Like someone mentioned in the questions earlier, that people quite often miss the connections at the horizontal plenums for shear. And if those connections are not in manufacturer's details, well, that may be the only thing that has to be submitted. You can get that a lot quicker and a lot cheaper than having the entire system designed. So, disaster number 2, Andy, I'll turn it over to you.
All right, so you bid the job based on this one makes me the bad guy, but you bid the job based on sizes shown on the drawings, and I or your delegated designer came up with heavier sizes or a more expensive design. So go through all the bullet points. It all leads to the last one. But so basically, a lot of times the ORs provided a design that's not feasible, whether that's difficult connections or just connections that aren't feasible. They didn't necessarily consider deflection. We've seen engineer of records put shear walls at slip connections, which makes crazy, ridiculous detailing required to make that work. A lot of times the engineer of record didn't read the footnotes, so this might come into play with them looking at a table out of the SFIA tabulated data, like the footnotes to the right there. So basically it would assume that your wall is fully braced, which would be less 4 foot on center or tighter. Their design might require web stiffeners, which is not something that's standard. You're not going to necessarily install web stiffeners at the top and bottom of your studs, because that's a lot of labor and a lot of extra material. So that's why we might come up with a heavier stud than what was the engineer record specified. So basically, like I said, a lot of times it boils down to the engineers never learn cold form steel. So they're opening up a catalog, they have a basic idea what they're doing, but it's basically why you hire a specialty structural engineer, because they and we're the experts and can help you through some of the things the engineer of record might not know. So disaster number 3 is the other side of the coin, where you hired a good specialty engineer to do your delegated design, and we came up with lighter sizes than what are on the drawings. But either the UR is insisting you build it the way it was originally shown, or the GC is asking for a credit for the lighter sizes. So sometimes we'll see the reasons aren't necessarily clear, but we'll come up with something more efficient and less expensive. And we recommend you working with your engineer to make your case. You know, we're already submitting calculations, so the engineer record has them to see where we came up with our design and why it's the appropriate design. And this actually ties into one of the questions that we just got about anchors. We've seen a requirement for screw anchors or something else other than PAFs for connections, and you know it's not really clear what the reasoning behind that is. And you know there are more efficient ways to do your top and bottom connections. We've also seen in specifications a requirement for PAS have to have a 10 times safety factor on them. So that can actually be detrimental to the structure. If you have to provide, if I'm designing the connections for 2 or 3 times more than what they need to be, you're going to have 2 or 3 more times as many PAFs. To get that in a small area, you're going to start busting out concrete, especially in post-tension concrete, to the point that you don't have a viable structure. So hiring a good special engineer, we can make this case for you. Another place is the bridging requirement, where regardless, they say no bridging has to be 4 foot on center. When that, in a lot of cases, for curtain wall framing, isn't the factor for the design. So you can go to 5 or 6 foot with your bracing. So when they're asking for credit for the lighter sizes, you really shouldn't be punished for that, for your engineer's efficiency. If the sizes were on the drawings, every subcontractor was bidding based on those sizes. So you shouldn't be punished for the fact that what was on the contract drawings wasn't correct. So, and this kind of goes back to that good relationship. If you have a good relationship, your engineer may be willing to assist you in your arguments and help you out to provide proofs for, why you should be able to use those lighter sizes.
All right. Well, that gives us to our last disaster, disaster number 4, coordination with other delegated designs. So as many of you know, that when the project starts, a lot of times you haven't even been contracted on the job. And the same goes for some of the detailers, some of the curtain wall designers, some of the, sometimes there's delegated design drawings for the exterior cladding. So as the folks that are designing the steel or installing the steel that's going to hold up that exterior cladding, you've got to wait for your specially delegated design drawings to come in. The curtain wall guys have to wait for theirs. The truss guys have to wait for theirs. So a lot of times there's a lot of coordination that is not ready yet when it's time for you to do your design. So what happens is you're waiting for these drawings to come back, and when they do come in, all of a sudden they don't match. So here's one example on the screen. The trusses went in and they're down below the level of this concrete block wall that went up. So when they went to put their trusses in, they're pre-manufactured, they just notched out the block to get that truss in place. Here's another example. If you're designing a ribbon window and there's a door in it that goes all the way down to the ground, now it looks like there's a nice sturdy jam stud on either side of that door opening, but what if that jam stud has not been designed to carry the little knee wall down below that? And this doesn't look that bad. The knee wall is not that tall. There are super tall windows, but sometimes you see this situation where the knee wall comes up 4 or 5 feet, and there's got to be a moment design down there at the base. And this is what has happened here. There's a ribbon window, a spandrel window, and there's that moment connection that had to be put at the very bottom. So again, if you haven't accounted for this in your bid, these are not cheap connectors. And the hard part is the labor, drilling those big fat anchors down into the concrete to hold this in, and then putting all those screws into the stud. So something that if you have not accounted for it in your design, and you've got a long spandrel window that has to have a bunch of these, like this building right here, then how do you account for that? Because it can be something difficult. In a curtain wall window situation like this is a project that I did many years ago in North Carolina. We had these spandrel beams at the perimeter, and we had to bolt it to the side of the slab at the second floor and the side of the roof slab, and then put kickers up in there. But when there's deflection at the roof or deflection at the center floor, second floor, where is that deflection going to go? And it's got to be taken out at the window head. And a lot of these window manufacturers do not have deflection details for the top of their windows. So this is a deflection detail that Andy's company came up with, but they've got this special caveat. Note is in red, it's clouded, all capitals, and architect, engineer, verify, general contractor coordinate to make sure that this slip connection, it will work and can be installed properly over the top of the window to allow this movement. And any slip connections, as many of you know, is becoming more and more important to make sure that the rain screen and the water resistant barrier and all those barrier systems maintain all the way through, so that there is accountability for movement, for that whenever there's a detail for movement, that has to be carried all the way through the wall. And a lot of times the architects do not carry that through as far as their design and how the exterior works. So those are the disasters we're going to talk about. Let's also talk about avoiding the pain. And we're going to give you 6 steps. And the first one we've already mentioned, partner with your specialty engineer early. Get to know them, work with them, have them on your speed dial. Then they can give you designs up front, and you're not surprised by some of this stuff. Send them your architectural, structural specifications. Let them read through it. As they provide their bid, they may give you information. They may say, hey, even though we usually design brick veneer for L over 600, there's a requirement in your spec that says L over 720, and therefore this stud that they called out isn't going to work, and you're going to have to go heavier. And I know this is an issue because you're trying to bid apples to apples, but if you don't bid it right and you do get the job, then you've got to pay for it one way or another. You've got to do that right design. So get with the guys early and make them your friend. All right, Andy?
So like Don said, become a good customer for your delegated designer. If you have a good one that you like working with, there's a lot of benefits to that. There's the potential for free upfront service, help in the bidding process. Your engineer can provide you a proposal up front, potentially give you some sizes for various situations that, you might not have a good feel of. Also reviewing the specifications, the structural drawings, they might have some weird things in, either of those items, the bridging at 4 foot on center, heavy minimum thicknesses, 54 mils. Sometimes we've seen 68 and 97 and told our client, hey, you want to qualify this in your bid because this is 97 mils is ridiculous. You're not going to need that for a 3 foot tall stud. We've also seen additional design requirements, or the big bad word that most of you don't like to hear, welding. Might start looking at structural details and see that they're requiring you to weld things, and obviously that's not the best way to perform cold form steel framing. So we'll help you find those things. So and a good relationship often results in better assistance mitigating a lot of the disasters and other disasters. So those relationships are important.
That's right. All right, step 3 of 6. Read contract documents carefully, especially the specifications and the general notes, and have your delegated designer read them too. And sometimes the requirements are hidden in an entirely different specification sections than the 54,000 or 92216. They may be in the gypsum requirements. They may be in the tile requirements. They may be in the mechanical requirements. I did a project in South Alabama where we designed a roof truss, and I didn't leave an opening for a 5 foot by 5 foot duct. Now the ductwork was shown on the mechanical drawings as a single line, and I missed it. It was my fault. But what the mechanical guys do, they just took a web right out of that truss. We had to reinforce it. But the question is now, whose fault was that, right? I mean, it was my fault. It was our contractor responsible. We were able to work with them and get it worked out. But this is why you want as many eyes as possible on those documents, on the general notes, on the architectural and structural. Make sure you're working from the right set of documents, as Andy showed you how you can go in and check what building code that is. And this is something that the specialty engineers do every day. It's different in different states, different in different jurisdictions. We had one question come in asking about what says whether or not we've got to make submittals to the city. That's up to the city. Most jurisdictions don't need to see the specialty submittals, but there are some jurisdictions, especially out on the West Coast, that want to see all this stuff. So again, it will depend on the city. If you're working with an engineer of record or specialty engineer that has worked in that jurisdiction before, they will be able to give you a better idea of what's going to be required for submittals. Avoiding the pain, step 4. Make sure the date version of the building code in the drawings matches what is in force when your structure is being built. Andy?
Yeah, so this will be in your in the structural general notes. So you can look in there and it'll have the building code. Typically, it is based on when the structural drawings are issued. And then a way to check what the correct code is, if you go to ICC, they have a code adoption map. So say we want to click Virginia, it'll take you to what the applicable code in Virginia is what has been adopted as of that date. So currently Virginia's adopted 2018 IBC, and so that's what any newer projects in Virginia should come out with. And for the most part, that's about where the states are at, but different states some are way far off in the past and some are a little bit more updated than that. And this is an easy check to go here and you can see what the correct code is. And this is what should be listed in the structural general notes.
All right, avoiding the pain, step 5, be nice. And when I say be nice, I don't mean being weak, but you've all been in heated discussions on projects with the general contractor, with other contractors. People are pointing fingers. People are thinking about how much it's going to cost them. But please try not to get emotional about these things. Think about the kind of person you like dealing with. Think about everybody is usually trying to get to the same resolution, getting the project built. And it's so much easier to deal with people when they're nice than when they're adversarial. Some people use that as a negotiating tactic, but remember, sometimes it's going to cost you money. Sometimes you're at fault. You partner with your specialty engineer, partner with others on the construction team to try to make it so everybody is going to work out. But don't just try to force blame and costs on other people. Try to work together and be nice and work things out a better way. And document everything. Andy, I'll let you start out and I'll finish this one up.
All right. So when conditions don't match the contract, flag them early and in writing. So now that can be in the contract documents. There can be discrepancies between the architectural and structural drawings. Often, I'm sure, obviously you guys get out into the field and everything is built perfectly and matches the structural drawings. There's no slabs out of place. Those kind of things you want to document early and respond to in writing when you get out there and the slab actually is out of place, because that's going to affect your framing, the connections, and something you're going to have to work with your specialty structural engineer to figure out a solution, because obviously they're going to dump figuring out the solution onto you. And job site photos are always important. Take pictures of the problems, send them to your specialty engineer, and just those job site photos are documentation of the problems. And a picture's worth 1,000 words. To you, to your specialty structural engineer, and to the GC who you're trying to explain the problem to as well. Don?
And really, there's no excuse for not taking job site photos. You've got cameras on your phone. You've got cameras on your iPad. Everybody's got cameras out there, and you should be taking pictures as often as you can to document this material. And I'm not talking just to the engineers. I'm talking to the contractor at the end of each day, at the beginning of each day, at the beginning of each shift. And the reason, because if you document everything appropriately, it's less likely that people are going to argue with you about what's being done. And as it says down here, that a lot of times the general contractors will have these systems that are built so that you can easily document this stuff. Now, if they don't, if you're taking job site photos, one thing that I do when I get out on a job site is I will take a picture of where I am. For example, when I get off the elevator, get off the stairwell, I'm on the 11th floor, I take a picture of that sign that says I'm on the 11th floor, so it makes it easier to follow through my photographs and see where I was in the building as I was going through this. Because on multi-story high-rise, multifamily residential, every floor looks almost exactly the same, and it's easy to forget where you were, where a picture was taken months or years down the road if litigation comes up or disputes come up. So make sure you do that with job site photos. I mentioned an item here, change orders and getting paid. Oh my gosh, there's an entire different webinar on that I think we presented at AWCI years ago. But all of these things have cost impact, and there are books out there and legal documents on how to get paid for change orders. But the better you document it, the more likely it is that you are going to be paid. A former president of AWCI once told me that his father told him this early on in business. He said that if you act like your project is getting ready to go to the courthouse and you document everything like you were going to have to go to court with this thing, then the likelihood is going to be very small that that's going to happen. So document, 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 It's so important throughout the process. You think you won't need it, but you've got it just in case you do. So to follow up, I'm going to give you a list of resources. First of all, the Cold Form Steel Engineers Institute. I've mentioned that as a source for engineers that know this stuff, but also this is their webpage at cfsei.org. There's a little button over on the right-hand side that says free publications. That button doesn't work. So what you have to do is go up to the top under publications, and you click on the drop down and then click on free AISI standards. That will get you books like the Code of Standard Practice, AISI S202, as well as the structural and non-structural standard, AISI S220 and S240. All you have to do is log in. You don't have to pay anything. Some other resources that are out there. The SBCA, Structural Building Components Association, has this document, Cold Form Steel Building Component Safety Information. Gives a lot of information about bracing and handling and transport and lifting of trusses and wall panels and other built-up components like that. So an excellent resource. This one is not free. It's $127. But again, if this is something you're doing, it's well worth it if you're a component manufacturer. There's a magazine primarily for structural engineers, but it's free to anybody to download this or look at it online, Structure Magazine. In 2013, they had an article on delegated design. This is a link to that article and a free download that goes with it. The American Institute of Architects have a contract, which is the standard form of agreement between the contractor and the consultant for delegated design services. So if you are a specialty engineer or an architect and you want to contract this work out, this is a nice way to do it. A lot of these delegated engineers have their own contract forms, or manufacturers have these forms that they typically make you sign that talks about billing arrangements and who is responsible for everything, and they reference some of these code documents that we talked about. Another additional resource is BuildSteel at buildsteel.org. There's a short article on does delegated design make sense for cold form steel interior framing applications, and they echo some of the things that we talked about before, that most of the time it doesn't, but there are some conditions where it does. And then the Council of American Structural Engineers, we showed this guideline for especially structural engineers earlier, but they also have an agreement for client and specialty structural engineer. It's very similar to the AIA document, but this would be more likely the one that the engineer would use if they're contracting with a contractor or subcontractor. And then with your handouts, you can see there's a little button out on the side that says handouts. There are 4 of them. One of them is the slides that go with this presentation. And the other 3 handouts are these 3 tech notes from the Cold Form Steel Engineers Institute. And Andy, you want to say anything about these, the tech notes?
Yeah, so I mean, I think they're good resources. That CFSEI has a lot of resources that if you're a member, you can download for free. On a number of different topics. A lot of them are more geared towards engineers, but you know, these couple give some good information. Coordinating with CFS with metal buildings, you know, we talked about that. The differences between structural and non-structural, there's some good information in there. You know, what needs engineered, what doesn't. And then temporary construction bracing of walls. You know, load bearing, obviously that has to be done. And that temporary bracing is very important. So just some good information, and you know, like Don said, this is included with the packet. So,
all right. So these were the learning objectives. I think we went through all of them. And what else do we have for questions, Tal?
One more question here. What happens when the contract documents have no submittal requirements and afterward the architects say they want shop drawings?
That is exactly like when on the contract documents don't have requirements for a wall built here, but they come back and they say, oh, I want you to build a wall. You give them a price. So they say, we want contract documents. Well, you go to your special engineer and they'll tell you how much it'll cost, and then you give them the price. And well, if they pay it, then that's great. You get your engineer to do it.
Well, those are all the questions we have. So on the behalf of AWCI, thank you, Andy and Don, for this presentation. Thank you for all the viewers and attendees. Please visit awci.org/education for upcoming webinars and events. Thank you for attending. We'll see you next time. Bye-bye, everyone.